In C#, properties are ways that we can have more control over how the fields in our program, so our first name and our last name of our person, for instance, are accessed. We can control who can set these variables, who can read from these variables, and we can also set up what happens when these are set or when they're read from. And the reason we would want to do this is closely tied to something that we call encapsulation. And in programming, encapsulation means making things hidden whenever possible, controlling what other code can look inside of our classes and can directly access the internal information of that class. And the more that we can make our code encapsulated, the more our code, for instance, is interchangeable. So if you think of a car, I can take a piece out of the car and I can put a new piece in the car, and I don't care what's inside that piece. So for instance, I can take, say, the air conditioning system. I can rip that out, I can put in a different air conditioning system, and all I care about is the connection points. All I care about is the outside of the air conditioning system, where it hooks up to the vents and where it hooks up to the electrical in my car. I don't care about the inner workings because nothing else in my car cares about the inner workings. And that's what we want to achieve with our code. So just as a sort of counterexample, we have a very simple program where we create a person and then we have some other method. And if I were to pass my person and call some other method with my person, then what's going to happen is some other person is going to reach in and they're going to change my person. So when I get my person back, my person has now been changed, and that's not obvious. This is not encapsulated code. So let's take a look at how we can use properties to solve this and many other sort of data management problems. This is the basic structure of a property. Just like a variable, we declare an access modifier and we declare its type and we give it a name. But then we open brackets, almost like we're creating a method. And inside, we have two what we call accessors. We have a get and a set accessor. The get accessor is used when we read my property, and set is used when we write to it. So as you can see up above, I can use my property exactly like I would use a field or any other variable. So it doesn't change outside of my code. The only thing that it changes is inside my class. And this won't currently compile because I'm not actually doing anything. I need to be returning something with my get. And ideally, I want to be doing something with my set as well. And here we have a fully fleshed out property. And what I've done here is I've created a private variable and then a public property, and these are connected. So we refer to this private variable as a backing field. This is the field that backs our property. And in the most basic sense, what a property does is when we call get, it returns the value of my property, and when we call set, it sets whatever value we've passed to that backing field. Now you'll note we have a keyword here in blue called value. Value is whatever value was passed into my property. And the type of value is always the same as the type of the property. So if my property is a string, value will be a string. If it's an int, it'll be an int, and so on and so forth. Now, right away, we've basically just created what we had here with first and last name, so we don't have any benefit. But what we can start to do is we can start to control who can talk to the get and the set. And the way that we can do that is we can actually make them private. So what happens here, and you'll note that I already have an error, is I can no longer read the value of my property. More commonly, what we want to do is we want to put this on the set. And we have essentially created a read-only variable. Anything can read the value of my property, but nothing outside of this class can set the value. So you can already start to see some of the power that we get by using properties in C#. Another way that we can set properties up is by using something called an auto-implementing property. So in this case, I've removed all of the logic and I've removed my backing field, and I now just say get and private set. This is auto-implementing. So what's happening under the hood is C# is creating a backing field that we can't see, that we can't access through code. It's sort of internal to the property. And same as before, we can read and we can write, but I can individually set what can read and write. And as you see up here, while I can read the value of my property, I still cannot set the value of my property. So what we have now is exactly equivalent to what we had before, only we don't need to actually create the backing field ourselves. But where the real power of properties comes in my opinion, is that you can actually add whatever logic you like inside of both the get and the set accessors. So you can treat these as you would any other method. So what you can see here is I've set up the first and the last name as properties, and inside of the first name, we actually perform a check. We're doing data validation. So this is something we can typically only do with methods, but here we do it with our property, which to everything else appears just like a variable, but then under the hood, we're checking to see if we actually have valid information, and we will refuse to fill in the first name if we weren't passed something that we expected. This can also be great, for instance, for event-driven programming. So we could hook up an event here. Whenever the first name is set, we can inform other things in our code, which again is something very powerful. And here with the first name and the last name, I've mixed to where anything can set the first name, but on the last name, I've done an auto-implementing property, and I've defined that you cannot, once you create our person, change the last name. So this might be used for something where you could set a different first name as a nickname, but the last name cannot be changed without creating a new person record. And so hopefully this starts to show you a lot of the power around what you can do with properties. And before we wrap up, just one final note on conventions. By conventions, we use a Pascal case for the naming. So we use a uppercased first letter on every word. And then for any backing fields, and this tends to go for fields in general, we want them to be private. We don't want our fields ever to be public. We want to use properties if we need things to be public. We want them to be lowercase, and oftentimes if something is a backing field for a property, we'll use this convention of putting an underscore, which is just sort of an extra reminder to the programmer of don't directly write to this, don't directly read from this, go through the property instead. So now you've seen how properties relate to fields, and you've seen some of the powerful things that we can do with properties. We can control who can read and write from them. Every time a property is read or written, we can respond to that. We can add logic around setting and reading variables. And in newer versions of C#, there are even more fun features that they've been adding. And just to show you one fun one real quick, as you can see with the full name here, we've used this special syntax, and this is called an expression-bodied member property. And what this is this is a read-only property that then returns first name space last name. So we can use this syntax, which looks a lot like C#'s Lambda syntax, to very quickly and very cleanly create a read-only variable that then does some internal logic. That's pretty neat. So I encourage you to read around, check out a couple of code examples, and find new and interesting ways that properties can help you write more encapsulated and therefore much cleaner and easier to maintain code.